Hi, today's presentation is about auto-scaling in OpenStack without telemetry. I'm Dat Vutuan from Viettel Group. The other speaker, Kian Nguyen is busy today, so he cannot join me. We will have 4 parts today. The first one, what is auto-scaling and what auto-scaling can do. The second one, OpenStack auto-scaling with heat and telemetry. The third one, and talk about what are the problems with telemetry. And the final, I will introduce our architecture with Faythe and Prometheus. So what is auto-scaling? Auto-scaling creates a target tracking scaling policies for the resources in your scaling plan. These scaling policies adjust resources capacity in response to live changes in resource utilization. And in most architecture, auto-scaling is simply the combination of 3 steps: metering, alarm, and scale. So auto-scaling in OpenStack with heat and telemetry. In OpenStack, by using predefined rules that consider factors such as CPU or memory usage, OpenStack heat will add or remove additional instances automatically when they are needed. The architecture, the core component providing automatic scaling is orchestration, which is heat. The template defines rules to evaluate system load based on telemetry data to find out whether there is need to add more instances into stack. Telemetry does performance monitoring of your OpenStack environment, collecting data on CPU, storage, and memory utilization for instances and physical hosts. However, there are some problems with telemetry, especially with our rocky OpenStack environment. First, telemetry projects are lack of contribution, which I think is the most important factor of an open source project. As of the Queen's release, the telemetry has lost several developers. The development of PromQL and ALDH has stopped. Gnocchi was moved out of OpenStack in June 2017. The integration between Gnocchi and ALDH is really not good. Gnocchi is unmaintained. So Telemetry is only capable of collecting OpenStack related metrics from instances. How about application data? Customizing in telemetry is not easy. How about custom rules, custom metrics? In order to custom rules and adding new metrics to telemetry, 3 different projects need to rebuild and reinstall. Telemetry isn't plugin, Gnocchi to store new metrics, and AODH to able to be evaluate new metrics. And one more thing, RabbitMQ was under heavy load due to telemetry workload. If telemetry gets stuck, it queues overflow, and ALDH listener doesn't support high availability. Next, I will talk about our problem. We use Prometheus ecosystem to monitoring the whole infrastructure system as well as applications. So why we use Prometheus? Prometheus features a customizable toolkit and delivers metrics without creating lag time on performance. Prometheus also support a wide range of exporters. Prometheus also has a really nice query language, PromQL. So I was showing you the auto scaling is a combination of 3 steps before the metering, alarm, and scale. So in mapping to OpenStack, Heath and Telemetry, the Ceilometer and Connective is in charge of metering and AODH for alarming and Heath for scaling. So we use Prometheus stacks to collect and store metrics and Heath for scaling, and we need a new one to do alarm based on metrics from Prometheus. Here we introduce Faythe, an open source software we build ourselves, working as a bridge between any cloud platform from OpenStack, Google Cloud Platform, Amazon Web Service to any monitoring system. So the old architectures with Heath and Telemetry will move to the new architecture with Prometheus, Prometheus exporters, and Faythe. So how it works? Prometheus collects and store metrics from a set of Prometheus exporter. In OpenStack, we use OpenStack SD config to auto add or remove instance by querying OpenStack. We add a label and query OpenStack instance list using instance metadata. Basically, we add metadata to instances, and based on that kind of metadata, we add a new label to metrics. And then Faythe periodically checks scalar rules user-defined PromQL expression by querying Prometheus to evaluate query is satisfied or not. If the rules is satisfied, then trigger a scale action. From there, Heath will take care of the rest. Here is an example from our system. When system on peak hour it had a really high traffic, so we need to scale more instances to serve user requests. When the system in off peak hour, the traffic is really low, so we need to scale in to remove instances for other applications. So why we use Faythe and Prometheus? As I said before, Prometheus provide a very flexible query expression, and Prometheus also support a wide range of exporters, so many metrics can be used or combined with each other. We can fully handle trigger scale action, method, number of retries, or kind of delay. And Faythe also has its own cluster mechanism. We also have web UI and HTTP API. So here is our web UI. You can specify what kind of query you want to input into query, and the duration, interval, text, description, and so on. So this is our UI. You can choose different cloud from the cloud input, and PromQL query goes here. The interval is the delay between each PromQL check. The duration is the total amount of time from the beginning of the query happens to when the action triggered. Cooldown time is the time between two HTTP action. Okay, let's go to the demo. Here I have one instance which has CentOS 7.7 image. Here I have a hit stack with a flavor M1 medium and CentOS 7.7 image. I have one dummy PromQL which counts the number of Faythe instance. Okay, let's check if the number of Faythe instance equals 12. The interval of 10 seconds, 1 minute duration, and cooldown 1.5 minutes. So for the URL, I copy the scale out URL of the hit stack. Okay, that's okay for the scale out. So let's create another for the scaling action. Okay, repeat the steps, copy the scaling URL. Okay, let's check if we have two scalars. Okay, let's go. Let's wait. Boring step. It may take 1 minute for Prometheus exporter to Prometheus to scrape metrics from Prometheus exporters, and another minute for the scalar. So that may be 2 minutes, up to 2 minutes. Okay, another instance. Another instance having CentOS 7.7 image and M1 medium flavor. Okay, delete scale out, scalar. Okay, remove one Faythe instance. So the number of instance less than 12. Okay, it's 11 now. And wait for another 1 or 2 minutes. So one instance is being deleted, it works as expected. Okay. So thank you for your attention. If you have any question, please ask me now or feel free to contact us via email on the screen. Thank you.